All right, so I'm going to keep going on this final exam review, or this might be another question that I just posted in the regular class. So I'm going to look at the normal distribution, and this was out of lesson 6. And I know some people had a tough time with it, but let's go ahead and look at a couple of the questions. And I'm going to show you how to do them with SALT, and it'll be really easy. And remember, you can use it for your final exam. So just go back in there and go to quiz 5 or 6, and you can open it. So for number 2, the average price of a bag of coffee in certain cities is normally distributed. All right, that's important right there. Normally distributed with a mean of $11.5. Okay, so I have my mean and a standard deviation of $2.7. All right. What proportion of coffee bags in the city costs less than $10.54? All righty. So I have everything I need. I have normal distribution. So I know I can use the really pretty bell-shaped curve that I've been using. I have the mean, the standard deviation, and I have less than. Let me do this. Less than. So this is also an important thing right here. I'm going to put it in a different color. I'm going to put it in blue. All right, so I'm going to go back to the SALT, okay? I was using binomial before, but now I'm going to use normal, okay? And remember, if I go back to what I had, my mean was 11.5, and my standard deviation was 2.7. Make sure I did that right, 2.7. Okay, so now I need to finish it. Less than $10.54. Okay, so it's a left-tailed because it says less than. So what I'm doing now is, let me push this up so you can see this. I want to make this area in orange less than $10.54. So I go over here and I change it to $10.54. And if you can see here, it's between 8.80 and 11.5. So it's right here. So, and it's less than, so I'm great. So I have everything I need. All I need to do is get this value right here, and that is my answer. So let me go back and put it here so you can see it. So the answer for this one is, what proportion of coffee bags in this city costs less than $10.54? It's 0.3611, because I would round it up because it only wants 4 decimal places. Okay, so let's do another one. All right, suppose the weight of male babies less than 2 months old is normally distributed. Okay, there it is again, normally distributed. I'm going to put that again in yellow, with a mean of 11.5 pounds and a standard deviation of 2.7 pounds. What proportions of babies weigh between, okay, that gives me my direction. I'm going to put it in different color. And here's the rest of the stuff I need. 9.98 pounds and 14.41 pounds. So I'm going to do that. All right. So I'm going to go back to my SALT. I'm going to put this. Oh, look, it's right there. We're good. Okay. So I think, is that basically, yeah. All right. So that's the same mean and standard deviation. And all I need to do now is do the between. So I'm going to do between. All right. And the lowest value it wants me to do is 9.98. So I'm going to put, 9.98. And then the upper value it wants me to put is 14.41. So this is going to be 14.41. Okay. So I'm showing it's going here from 9.98 all the way up to 14.41. So I'm concerned about this area here in orange. So I'm going to copy it over here from SALT, and you can see it when I do it this way. Okay, so what is the proportion of babies weighing between 9.98 pounds and 14.41 pounds? It's 0.5727. So that's the answer for that one. Okay, so let's do another one. Okay, this one's a little bit different. So this is when I have the percentage, but it wants me to give an actual value. So think of it this way. It gives me the percentages, the area in orange, and then I need to find that exact value on the x-axis. All right, so let's look and see what this one says. electric bills in a certain city have a mean of, so let me do that, $120.82. Assume the bills are normally distributed with a standard deviation of $11.50. Assume that the value separates the lowest 52% of the bills. All right, I'm going to do that, lowest 52% of the bills. All right, again, I am going to go to SALT. Okay, same thing. I'm going to do this, which was 120.52. And make sure, sorry, some days, nope, 128.2. Sorry about that. Okay, and then my standard deviation, I'm going to go back, is 1150. So I go here, put 1150. Okay. All right. And I'm going to do left because it said, why am I going to do left? Because it said lower 52%. Okay. Again, I've got my mean, I've got my standard deviation. And now what I want to do is I want to change this to 52.52, which is really 52%. And you can see here, lower 52. And so it's going to give me this area in orange is 52% of the data. And if you look, with this being the mean, and remember with normal distribution, 50% is on the left of the mean, 50% is on the right. So I'm pretty accurate in that. So all I'm going to do is get this value right here, and I'm going to plug it in so you can see it. So find the value that separates the lower 52% of the bills. So that amount is $121, and I'm going to round up. So I'm going to do this. It's going to be $121.40. Okay, so that's how you do that one for those normal distributions. All right, let's do a couple more. So here's another one. In a large biology class, the scores of the final exam were approximately normally distributed. Okay, again, got normally distributed with a mean of 80.5 and a standard deviation of 9.9. Okay. What proportion of the final exam scores were greater than, okay, for this, remember, I'm going to do it a different color just so I know, greater than 76.3. All right. So I'm going to go back to it. The mean was 80.5. And the standard deviation was 9.9. Okay. All right, and it said greater than, so I'm going to go right-tailed. And the reason I do that in blue is because it tells me the direction, and I have to do that in a different column. So it was greater than 76.3. So I'm going to put 76.3. Okay, and I know I'm correct because look, I wanted the proportion or the area greater than 76.3. And it's that area in orange. So then that tells me this. I'm going to take it and copy it over so you can see it. The proportion of final exams that were greater than 76.3 were 0.6643. So that means 66% of the class had a score greater than 76.3, which makes sense because my mean is pretty high. All right, so that was the normal distribution questions for the final exam for just the regular without changing the standard deviation.